Okay, boys and girls, here we go. The last lesson of this semester, the last lesson of topic 4 before we close out the year, and we are factoring algebraic expressions, which means we are doing the opposite of what we did yesterday when we were expanding algebraic expressions. Okay, so yesterday you might remember that we might have started with something like this, 3 times 9a plus 8, and then it wanted us to expand that by distribution. So we would say 3 times 9a, and then plus, and we repeat the multiplication of the 3, and this times 8, and then we'd multiply 3 times 9 for 27 times a, and then 3 times 8 is 24. And you'll notice that this is where we're starting today. And so the problem today wants us to work backwards, wants us to go from the answer, what we would have had yesterday, back to the original problem. That's what we're trying to do. We're trying to what's called factor the algebraic expression. Okay, so the first step is always to find the GCF. And GCF, you know, stands for, say it with me, greatest common factor. The biggest number that can divide into both of these terms, the biggest number and the most largest combination of variables that also divide evenly into each term. So in this case, we're looking at 27 and 24, and we know that's both those numbers are divisible by 3. So we will start off by saying the GCF is 3. If you don't understand that the GCF between 27 and 24 is 3, then do a factor tree. This is 3 times 9, 3 is prime. Then 9 can be factored into 3 times 3, and those are all prime numbers, right? So we'll circle them. And then 24 factors into 3 times 8, and 3 is prime. 8 factors into 2 times 4, 2 is prime, and 4 factors into 2 times 2, and both of those are prime. So then we're done. Now, is anything common between them? Yes, this 3 right here, and this 3. Those are the only two numbers that those factor trees have in common, the circled numbers, and so the GCF, we would say, is 3. It is that 3, that 1, 3. Okay, so coming back to our problem, we start by saying the GCF is our multiplier, and inside our parentheses, we will put the terms that multiply to equal 27a plus 24. So in other words, 3 times what, I'm looking right here, 3 times what would equal 27? And we know that would be 9. But then we also have a, so we have to put 9a. Let me try that again. 9a. And then 3 times, now I'm looking right here, 3 times what will equal 24? And we know that's 8. So there you go. That is the factored form, the factored algebraic expression. So we're going to put that answer right there. Okay, same thing here. We're going to factor the expression, 45y plus 5. And so we're going to think of the GCF first. What is the GCF? Well, we know that 5 can go into 45 and 5, so let's say the GCF is 5. I can't think of a bigger number that can go into either or both of those numbers. So we're going to start with the GCF and multiply it by one term plus another term. And in the first term, we know 5 times 9, but then also y equals 45y. And then in the second space, 5 times 1 equals 5. And so this is the answer right here. Let's take a look at this problem. It says complete the factored form of the linear expression, okay? So let's see. We have to judge what the GCF is. And in our answer choices, we see that our GCF is given to us as either 6y or 6x or 6. And we have to figure out which one of those is actually true. Okay, well, let's look at our terms. These are our terms. Is there an x and a y or either one in both terms? Is there an x in both terms? Is there a y in both terms? No. So we know that there can't be variable in our GCF. So that's out. That can't be that. It can't be that. So we have a B and D saying that our GCF is 6. Now we just have to figure out which one is correct. So let's look at this. Is 6 times 4x, is that equal to 18x? No, that's 24x. So that's wrong. It has to be answer choice D, right there. Good. Okay, here we have a different kind of problem. It says, find the possible dimensions of the sports field given if the width is at least 50 yards. All right, actually let's look at the next. Here is the picture of the field. It says the area is 630 minus 450 square yards. And so we want to find the possible dimensions of the field if the width is at least 50 yards. Okay, so let's come back to this problem. Well, we know right away that it can't be B. Do you see why? Tell me why. Take a minute to think about it. Good, if you thought that the width being 45 yards is too narrow, you were right. Can't be that. Okay, so let's see. What was the 630 minus 450D? I'm going to go ahead and write that. I'm just going to write that down here. Now, can we think of a GCF for 630 minus and 450? Okay, boys and girls, here's the way to think about it. Let's look at our numbers 63 and 45. What number can go into those two numbers? That's 9. So the GCF will be 9, but then we can also add a 0 because 600, they both end in 0. So 90 can go into 630 and 450. So 90 is our GCF. If you can't do that in your head like I can, or like hopefully, I'm hoping you can, but if you can't, do a factor tree. So we're going to take our GCF and we're going to multiply it by something minus something else. So 90 goes into 630 7 times, and it goes into 450 5 times D. Okay, so let's see. Looks like our clear winner is, which answer choice is it? You got it, D. The width is 90 yards and the length is 7 minus 5D. Okay, boys and girls, here's a problem. It's called error analysis. And it says your friend incorrectly factors the expression below as 6x times 5 minus 4xy. We want to factor it and try to figure out what error our friend made. So let's factor it first by finding the GCF. That's where we start. The GCF between 30x and 24xy. What goes into 24 and 30? That would be a 6, but then we also see that each term has x in it. So we have to put x in the GCF. Now we're going to write that down, 6x times something, take away something else. And so 6x times, I'm looking right here, what are we going to put right there that if we multiply it by 6x equals 30x? That would be 5. 6 times 5 is 30, and then there's an x there. Then now I'm looking over here. What am I going to put there that I can multiply by 6x to equal 24xy? That would be 4 to start with, right? That will give me 24, 6 times 4. And then I already have x here, but what do I need to add? I need to add the y. Okay, so we're going to take this answer and put it in that box right there. And then in the next part of the problem, we're going to explain what the error was. We're going to compare our answer to this answer right here that our friend gave, and we're going to explain what went wrong. Take a minute to think about that yourself. Here's an easy one. Think about the process. What is the first step in factoring the linear expression below? Here it is. Well, you know what it is. What is it? You got it. It is identify the GCF. Always the first step. All right, looks like the problems are getting just a little more challenging. Let's take a look and read this one. It says, a hotel manager is adding a tile border around the hotel's rectangular pool. That's important. Let P represent the width, and the length is 3 more than 3 times the width, as shown. Write 2 expressions that represent the perimeter of the pool. Okay, well, let's look at the pool. So here we have P as the width, and we have 3P plus 3, that's 3 more than 3 times the width, as the length. All right, now the perimeter of the pool is going to be, let's think about this. Perimeter is going to be the addition of all the lengths of all the sides. And we know in a rectangle that if P is the width, then P is also the width over here, and we know if 3P plus 3 is the length below, then 3P plus 3 is the length above. Okay, that's one thing. Now, let's write an expression for the perimeter. Okay, so that's going to be P plus 3P plus 3 plus 3P plus 3. Let's take a look at what that is. That is the width and the other side that is the width, and then the length, and then the other side that is the length. So we have 4 sides of the rectangle, 2 different sides, each occurring twice. So P occurs twice, and then 3P plus 3 occurs twice. Now let's add all that together. P plus P is 2P, right? So this one and this one added together is 2P. Then we have to add that 3P, that's 5P, and another 3P. How many P is that? That is 8P. And where are our remaining like terms? Our remaining like terms are right there, the 3 and the other 3. And how much is that? Plus 6. Okay. So there's one expression. Now let's write the factored expression. What's the GPS of 8 and 6? You got it. It's 2, and then I'm going to multiply by something plus something else. And that is 2 times 4, you got it, P, that's 8P total. And then 2 times 3 is 6. So here's one answer, and here is the other answer. Let's find them in the choices. Do you see them? Here's one. And here's the other one. Good job, boys and girls. All right, here's a good one. Let's look at this. It says reasoning. Which of the expressions have like terms? Use pencil and paper. Explain why the other expressions do not have like terms. All right, let's get going. Does the first expression, negative 5/6m plus 8m plus m, have like terms? Select all that apply. Yes, that has like terms, because they all have a similar variable, right? How about the next expression, 2y plus 2x plus 4? Nope. How about 5.25t plus 7.75t minus t? Yep, there's at least 2 terms that have t for the variable. And then the next one, 14m plus mn. Okay, are there like terms? Can we combine them together? The tricky thing is that this expression, oops, let me make that a little skinnier. This expression right here, no like terms, because it would either have to be 14mn or the other term would just have to be plain m. Then we could add them together. Because look at this one. 7xy minus 6xy. Are there the same exact variables in both x and y? Yes. That means those are, in fact, like terms. So we're going to mark that one too. And then this last one, 3 minus 5p, no like terms there, because they don't have the same variable. So those are your answers.